Hello everybody, my name is Alex Garbus, and today I'm going to be walking you through how to set up your Unity projects to be pixel perfect. Now, what do I mean by pixel perfect? Well, when you're working with pixel art, you typically want it to display in-engine just as it does in your art or image editing software. You don't want there to be any blurring or scaling. You just want it to be one-to-one between the game and your original artwork. Now, this sounds like it would be simple to set up, and for the most part it is, but then there are some parts of it that can be a bit of a headache, especially if you're developing for multiple screen sizes. So I wanted to walk you through the process I use for setting up Pixel Perfect. This is going to be split into two parts. During the first part, we are going to take a look at Unity's Pixel Perfect camera component, and in the second part, we're going to talk about setting up your user interface to be pixel perfect. If you wish to follow along at all or view my project files for yourself, you can view them all at github.com/alexgarbus/unitypixelperfecttutorial. So, I've got a couple sprites set up here. We've got our character named Pixel Pickle. We've got these tiles for just a quick map I set up. This isn't really related to pickles at all. I guess we could say it's a pickle factory. Let's go with that. It's a pickle factory. This game is about Pixel Pickle in a pickle factory. And then we've got a UI bubble. As the name implies, it is a bubble for containing UI elements. So before you begin, you're going to want to determine two values. Your first value is the pixels per unit value, or PPU. And what this is, it defines how many pixels of your art correspond to a unit within Unity's world space. When you're working in your art software, the pixels are the units, so you have a PPU of 1. But Unity uses its own world space unit system, and so you have to tell it how many pixels in your artwork correspond to a unit in Unity space. And typically, this is going to be the size of your tiles. So, for instance, with the tiles I've made, the width and the height of each tile is 16 pixels. So that means the PPU would be 16 pixels per unit. If you're not working with a tile-based game, which in most cases you are going to be working with tile-based if you're doing pixel art, but if for some reason you aren't, I would say make the PPU the size of your the width and height of your smallest square object. So like we have our character here who is also 16 by 16. But yeah, the next thing you're going to want to determine is your reference resolution. Now this is the resolution that your sprites, your pixel art is designed for. Another way to think of it is the screen, how many pixels are going to be displayed on the screen width and height wise. So for instance, since we have a PPU of 16, each tile is 16 by 16 pixels, and let's just use the hypothetical scenario here. Let's say you want your game screen to be 20 tiles wide and 20 tiles tall. Then you would have your reference resolution be 16 times 20 on both the width and the height, which would be 320 by 320. A good rule of thumb for picking your reference resolution is just taking a base aspect ratio and multiplying it by a certain value. So like the default value it gives us when we jump into Unity is 320 by 180. And that's actually just a 16 by 9 aspect ratio, but multiplied by 20. And we'll talk a bit more about reference resolution once we head into Unity, because for games like for mobile devices, it can be a bit of a trickier process for selecting your reference resolution. But for games for PC and console, you're typically going to be developing for a 16 by 9 aspect ratio, so you can just make your reference resolution that aspect ratio multiplied by a certain value. One last thing you're going to want to do before jumping into Unity is you're going to want to make sure all of your sprites are exported as PNGs. That is the file format that we're going to import them with, because it maintains transparency and it prevents any sort of quality loss because it does not compress your files. So typically in pretty much every image editing software, you can export your file as a PNG. And with all that done, we can go ahead and jump into Unity. So as you can see, it's not very clean right now. I've set up a base tile map and a some base scripts here, and but I've went ahead and reverted most of the settings to their defaults. So you can see here, this is a mess. Yeah, nothing's lined up properly. And we need to fix that. So the first thing we need to do is you can go ahead and select all your sprites by control clicking, or you can do click and then shift click to select all the sprites within a certain area. We want to set the PPU that we determined earlier. So in this case it's 16, so we're going to enter the pixels per unit as 16, hit apply, and everything's sized properly now, but you'll see the that it's pretty blurry. Which again, this is not pixel perfect. That's one of the issues. This is one of the issues pixel perfect rendering aims to avoid. Because we want the edges to be nice and crisp. So we need to prevent... So when Unity imports sprites, it has these compression settings, and we want to go ahead and disable all of them. We don't want any compression whatsoever. So set the filter mode to point, and then set the compression to none. We'll hit apply again, and as you can see, it's nice and crisp. You'll notice the pixels are still a bit distorted. You'll see some pixels appear larger than others, depending on where I move. But everything is crisp, so we're getting there. And real quick, I'll go over some of the additional settings for importing sprites. So for a tile map or an animated object that exists in a sprite sheet, you can open up the sprite editor here. Or actually, first, you set the sprite mode from single to multiple. Then you open up the sprite editor, and you can select the slice option, grid by cell size, and then enter a pixel size that's equivalent to your PPU on both the X and Y axis. And then you can also set a pivot point. I have them set as center here. This just determines like the point that transformations are performed around or sprites are sorted by. I'm gonna go ahead and hit slice here, and as you can see, it automatically sliced up the tile map into individual sprites, and then you just hit apply, and you're good. Now for UI elements like this UI bubble, we want to be able to resize the this without distorting it at all. And so in order to do that, you keep the sprite mode at single, open up the sprite editor, and you'll see these green squares on each side. You can simply drag those out to 9 slice your sprite. And so what this does is whenever you resize a UI component that uses the sprite, the corners will remain the same size no matter what, while the edges will scale according to the size you've set. As opposed to if it was just a single sprite, then the corners would resize along with the rest of the sprite and it would look distorted. So we've imported the sprites. Now there's a few more settings we'll want to change before jumping into the 2D Pixel Perfect package. You want to go to your project settings, go to quality, and for each quality level here, you're going to want to disable anti-aliasing. Anti-aliasing is the effect where it blurs the edges to create smoothness, which of course you don't want because this is pixel art. So for every quality setting in your quality settings, for every quality level in your quality settings, I mean, just disable the anti-aliasing. All right, looks good. And then we're gonna go to edit again, edit grid and snap settings, and for the move snap here, you can just select this little icon to change all three values at once. You want to set this to 1 divided by your PPU, so in our case 1 divided by 16, and you can perform operations like this within the Unity inspector. Just press enter and it gives you your result. Now what this does is it allows us to move our sprites on a pixel grid. So go select the little the directional arrows icon up here. Select this to begin moving your sprite, and ordinarily you can see it moves freely. So you can like set it to slide in between a set of pixels right here, which doesn't look natural since it's pixel art. So, but now that we've defined the grid and snap settings, if you hold Control, it'll snap the object to the grid. And since our grid is 1 divided by our pixels per unit, it moves along with, it snaps to the rest of the pixels. As you can see, whenever it moves now, it looks nice and natural. It fits in with the background. And that is the initial project setup needed for setting up Pixel Perfect. Now, you are also going to need a package from Unity called the 2D Pixel Perfect package, which can be installed from Window, Package Manager. Give it a chance to load. It's doing its best. It's doing its best. And I already have it installed, but if you don't have it installed, there will just be an install button here. You click it to install. And this has the Pixel Perfect camera component, which basically renders the scene to be pixel perfect. We've already done plenty of setup to make it pixel perfect, but as you can see, if I hit play, there's still some issues. You can see I can still slide in between pixels. There's still some pixels, like if you look at the lines, some are appearing thicker than others. And so so while we've gotten rid of most of the blurriness, the Pixel Perfect camera is going to do the rest of the work and ensure that everything remains completely crisp and pixel perfect. So you're going to go to the main camera in your scene and add a component, Pixel Perfect camera, and as you can see, it gives you a sort of it gives you some green boxes here that give you a preview. You want to select Run in Edit mode, and this will let you preview the changes in real time in the game window here. Now, this isn't a variable that gets saved. This is just for the editor, so every time you reload the scene in the editor, you'll need to hit this button again if you want to preview the Pixel Perfect camera in real time. And you'll notice there's a error up here. Because of the way Pixel Perfect rendering works, there are certain... if you're rendering at certain resolutions, it will not work properly, and it'll display this error message. So I'm going to go ahead and run through each of these settings in the Pixel Perfect camera and talk about what they do. These two are just the values we had defined previously, so the asset pixels per unit is the PPU, 16, and then our reference resolution is the reference resolution we defined before. In our case, we'll just keep it at 320 by 180. And so you'll see here, the dotted line is the reference resolution. It's everything that is rendered within the reference resolution, while the solid green line is everything that gets rendered outside of the reference resolution if you're rendering anything outside of that resolution. And I'll go ahead and explain that a bit further with the next three settings. These are all, the upscale render texture, pixel snapping, and crop frame are all variable depending on your needs. For upscale render texture, if it's enabled, it changes the rendering mode so that instead of also real quick here, go ahead and set this to 1920 by 1080 just to get rid of that error, because if you have it set the free aspect view in the Unity editor tends to generate that error message. But what upscale render texture does is, if it is enabled, it changes the rendering mode so that the scene is drawn as close as possible to the reference resolution you've set, and then upscaled to fit the screen. This can result in some pixel distortion at times, but is typically safe, and it also has the added benefit of pixelizing any sprite transformations you perform. So for instance, let's go to Pixel Pickle here, and I'm going to rotate them 45 degrees and squish them, or let's stretch them. Now, as you'll see, it's no longer pixel perfect. It's no longer lined up with the rest of the pixels on the screen. If we have upscale render texture set to true, it is. It's still it's still stretched, but it's pixel perfect. All the pixels line up. And so if you're wanting this sort of effect, it also, as you apply transformations, it continues to pixelize them. So if you're wanting this sort of super pixelated effect, then definitely go with upscale render texture. Let's go ahead and reset this here. Back to normal. Now, if you have upscale render texture disabled, you have access to the pixel snapping option. And what this does is essentially like how we defined with the grid and snap settings, where if you control click and move, your object will snap to the pixel grid. Pixel snapping ensures that the objects will snap to the pixel grid during gameplay. This won't affect their actual positions, but rather the positions they appear at. So you can have an object, let's say Pixel Pickle is positioned right here, and it'll keep this position during the gameplay, but if you have pixel snapping enabled, let's look here. If you have pixel snapping enabled, Pixel Pickle will that's a bit of a tongue twister there, actually. Pixel Pickle will now appear to snap to the grid. Again, this does not affect Pixel Pickle's actual position, but rather the position it appears in. And of course, if you have upscale render texture enabled, it already performs this behavior because it's rendering at such a small size. The next set of options here are crop frame X and Y, and what these do are, so if you look in the scene view, oh, this actually lines up pretty well. But let's say it didn't. Or, of course it lines up pretty well because it's 16 by 9. Let's say it didn't. Let's say the reference resolution is, let's subtract 16 from this, from both sides. So it no longer fits the screen. If you have crop frame X or Y enabled, it will not render anything outside of the reference resolution. Then if you have both checked, you can also select stretch fill, which will, as the name implies, stretch the viewport to fit the screen. You typically don't want to do this because it does result in blurring. It's a bit minor there, but it is still somewhat noticeable. And of course, the goal of Pixel Perfect is to render the pixels as perfectly as possible. So like I said, these settings are pretty situational. They really depend on your needs. My personal recommendations are, if you're making a game for a fixed aspect ratio, like let's say this is being made for PC and console, then we'll stick with a 16:9 aspect ratio. The settings I'd recommend are upscale render texture disabled while you have pixel snapping enabled, and crop frame X and Y are both disabled. We'll take a look at this here. It's a bit jittery, mainly just because I haven't perfected the movement scripts, but everything snaps. And that is what you would like with Pixel Perfect. The snappy, crisp movement. All the pixels line up. Now, if you were designing a game for a variable aspect ratio, like this is typically for if you're designing for mobile devices, or if you're maybe making a game where a PC game where the window can be resized, I would recommend having upscale render texture enabled, while still keeping crop frame X and Y disabled. This movement isn't as snappy as if you have pixel snapping enabled, but for variable screen resolutions, it is necessary to use this to avoid errors. And if you're developing for mobile devices, there's actually a tool you can use to preview that in real time, just as you would with the Pixel Perfect camera. It is a preview package, so in order to enable preview packages, you'll need to go to Edit, Project Settings, Package Manager, and make sure Enable Preview Packages is enabled. If it is, then you can go to Window, Package Manager, and look for Device Simulator. And it's not installed yet, so I'm going to go ahead and install it. Alright, so we have the Device Simulator installed. So now in the game window, you see this little drop down here. You can select the switch to the simulator, and this lets you preview the game as if it was being run on... You get a ton of different devices here. You get Apple, you get Google, you get Motorola, Samsung. You get this whole list here, and you can just switch between them. Make sure, of course, that you have run in edit mode enabled. And you can see how the game will look on these various devices. You can also rotate the screen to see how it'll look at different orientations. And here's where I was talking about earlier, how if you're developing for variable aspect ratios, you may want to play around with the reference resolution. Because as you can see here, if I go over to the scene view, we're currently using a reference resolution made for a landscape. So it looks fine if we switch to landscape, it fits fine. But if we switch to portrait, you can see it's pretty small. And so, and the opposite is true as well. If you switch these values, so it's 180 by 320, then portrait looks fine, while landscape, or actually landscape looks fine here. But it is still a bit zoomed out compared to the portrait view. And so a way to ensure that it'll have the same level of zoom on both portrait and landscapes is to just set your reference resolution to something square. So let's do 180 by 180. And then when you rotate it, you can see that the view is slightly different on both orientations, but also the zoom level is about the same. Let's go to the scene view also to observe this. So you know you can for sure see this part of the screen on both orientations. And this is something that you'll want to, if you don't have a good idea of how you want it to look, this is something to play around with. I'd say I usually think like either a square reference resolution or a portrait reference resolution is fine. You also cannot use your keyboard to control in the device simulator. Oops. Alright, so that about does it for setting up the Pixel Perfect camera in Unity. Now in the next part we're going to discuss setting up user interface to be pixel perfect, because user interface is separate from your actual world space objects, and as a result we're going to need to go through some separate setup processes for them. So see you in the next part, and thank you so much for watching.